hour is solving equations. Now, in college algebra, we had a day to solve linear equations. And then we had 2 days to solve quadratic equations. And then we had a day to solve absolute value equations and a day to solve equations with radicals in them. Today we have 1 day to review all that. So anything that's of equivalent level of difficulty with what you would have done in college algebra, if you've already done it, I'm just going to show you a good example in the book. Please refer to the book. Some math students don't like to look at the book at all. But this book in particular is very well written. It has great examples. Out in the side of the examples are typed the words for what is happening in each step, and you may need to look at that in the homework. What does linear equation even mean? How do you look at an equation and go, well, obviously, that's a linear equation? It's x to the first. There's no x squared or x cubed. It's a first degree equation. So when you see a first degree equation, you should flash back to about the 8th or 9th grade and go clear out the parentheses, and then you combine like terms, and then you get all your x's on one side and your constants on the other, and then you combine like terms again, and then you divide by the coefficient, boom, you're there. How long is flashing back to the 8th grade, Scott?
A long time.
Would you in any part of your life ever want to be an 8th grader again? No. No, never be an 8th grader again. Even though that's where I saw my husband for the first time. Let me show you the example on page 42, because even though I'm sure you're a professional linear equation solver, what continues to cause algebra students trouble is equations that have fractions in them. If I just give you an expression like let's say x over 2 plus 4, there it is, x over 2 plus 4. Can I clear the fractions out of that? Like, what are you wanting me to say? I'll say whatever you want. That's not an equation. You cannot clear out the fractions. You could get a common denominator and combine those so that you had a single fraction, but it would still be a fraction. It's not an equation, so you can't clear out the denominators. However, this example 1, if you have an equation, then you can clear out the denominators by multiplying both sides by the LCD. So anytime you're thinking clear out the fractions, stop and ask yourself, is this an equation that I can do the same thing to both sides, or is this just an expression? An expression, you could not clear out the denominators. You clear out the denominators by multiplying all 3 terms by the LCD, which is x minus 2. Your next line shouldn't have fractions in it anymore. That's why you multiplied by x minus 4 to clear, x minus 2 to clear out those fractions. And then it's just clear the parentheses, combine like terms, blah, blah, blah. There's another reason I wanted to show you an example 1. Whenever you clear fractions out of an equation, there's a caution. There's something you have to check for at the very end. I solved and I solved and I solved, and I came up with x equals 2, and it's so tempting just to circle it and say, that's my answer, x equals 2. Why can x equal 2 not possibly be the answer to that, or the solution to that equation? If you try to check it, if you put 2 back into that original equation, it's going to make both of those denominators 0, which is going to make both of those expressions undefined. You cannot use a proposed solution that makes the equation undefined. Not the equation undefined, but the expressions in the equation undefined. So the caution, whenever you clear out fractions, you have to check back and say, does that proposed solution make any of the denominators 0? If it does, you just have to mark it out and say that can't be a solution. If that was my only possible solution and I can't use it, then there's no solution. If I had two possible solutions and one of them made the denominator 0, I'd just mark that one out and circle the other one. But you can't ever let x be what makes the denominator 0. All right, that's your good example of a linear equation. Now, what about a quadratic equation? How do you recognize a quadratic equation? If you graph it, it's a parabola, yes. But if we're not graphing, we're just solving, how do I look at an equation and go, well, this is quadratic? It is second degree. Linear is first degree, quadratic is second degree. It has, the highest power is 2. It has an x squared, but no higher degree equation or expression. There are 3 ways we solve quadratic equations. We've done them so thoroughly, Algebra 2, college algebra, that I'm not going to do any more quadratic equations. I'm just going to point in the book. The 3 methods for solving a quadratic equation are factoring. And you have 2 good ones on at the bottom of page 45. When you see a quadratic equation, the first thing you need to think is, hey, I've got to get that in standard form. What does that mean, standard form of a quadratic equation? Constant? Yes. And then the whole thing set equal to 0. That's exactly right. That left-hand side has to be x squared, x constant. The right-hand side has to be 0. And then you can attempt to solve by factoring. That will factor either trial and error or grouping. Once you have 2 things multiplied together that give you 0, you say one of those things has to be 0. And you separate this into 2 equations, 3x minus 5 equals 0, or x plus 2 equals 0. That gives you those 2 answers. The second one's just a little bit easier. It's the easy kind of trinomial to factor. You only get one solution because both of those factors give you the same answer, x equals 4. So that's solving a quadratic equation by factoring. The second method is the square root method. And number 46, page 46, blue box at the top of the page, says if x squared equals d, then x is the positive or negative square root of b. Let's put some numbers in there so we can figure out exactly what that's saying. If x squared equals 9, and I just say, what can you square and get 9? The first answer that pops in your head is 3. But is that the only number you can square and get 9? Also negative 3. There are 2 numbers that you can square and get 9, both positive 3 and negative 3. And that's why this special quadratic equation says when you take the square root of both sides, you'll always get both a positive and a negative square root. When you hear yourself think, take the square root of both sides, bells and whistles need to go off. Don't forget the plus or minus. So 2 examples using the square root method. If you just have x squared equals 169, when you take the square root of both sides, you get positive and negative 13. If you have a binomial squared equals a constant, when you take the square root of both sides, you just get the binomial equals plus or minus square root of 5. Subtract 3 from both sides. And then that's the exact answer. If you needed a decimal approximation of the 2 answers, you could put negative 3 plus square root of 5 in your calculator. That's one of the answers. Negative 3 minus square root of 5 is the other answer. What's your if all else fails method for solving quadratic equations? If it won't factor, and if you can't use the square root method, you can always use the quadratic formula, which you sing to yourself to the tune of Pop Goes the Weasel. X is equal to negative b plus or minus the square root. That's the first thing I sing to my children when I rock them at night. X is equal to negative b plus some of the square root. And then when Heidi's like in algebra 1, she goes, holy cow! I remember that from somewhere. You just peel off the coefficients of the quadratic equation. The quadratic equation in standard form is ax squared plus bx plus c. You peel off those coefficients a, b, and c and plug them into the quadratic formula. Simplify as much as possible. A good example of that is example 5 on the next page. This equation, negative 2x squared plus 6x equals 3. First thing you have to do is get it in standard form. Is that equal to 0? Peel off the coefficients. A is 2, b is negative 6, c is 3. Plug them into the quadratic formula and simplify as much as possible. Now, I added a little middle step there because somebody always says, what happened to the, I don't know, what happened to this 2 or something? The way you simplify square root of 12 is to factor it into something that is a perfect square times something that's not. Take the square root of the 4 out of the radical, leave the 3 under. And then the most illegal thing you could do here is just cancel the 2 and the 4. That 4 is divided into both of those terms. So I factored out a 2 and then divided that factor into the 4. Canceled my common factors. There's my 2 exact answers. There's my 2 decimal approximations. All right. We've been doing that for a long, long time. So I can solve linear equations. I can solve quadratic equations. What about absolute value equations? Absolute value means distance. It's the distance a number is from 0 on the number line. When I say absolute value of negative 3 is 3, that means it takes 3 hops to get from 0 to negative 3 on a number line. So similarly, if I say the absolute value of x minus 3 is, let's say, 4. 4 is the distance. I want a number that's a distance of 4 units from 3. Can you squint really hard and tell me what's 4 units from 3 on a number line? You start at 3 and count 4 units away from that. 1 would just take 2 hops. I need something that takes 4 hops. And the hop can be in either direction. If you start at 3 and hop 4 to the right, where do you land? 7. If you start at 3 and hop 4 to the left, where do you land? Negative 1. So I know that has 2 solutions, 7 and negative 1, and I was able to figure that out just by picturing a number line in my head and jumping 4 to the right of 3 and 4 to the left of 3. If that had been x minus 3 is 72, I don't want to have to picture a number line and hop 72 to the left, 72 to the right. So the algebraic way that we solve that equation is by saying x minus 3 equals positive 4, a distance of positive 4 when I'm hopping to the right, or x minus 3 equals negative 4 will give me the answer if I hop 4 units to the left. That gives me the very same answers, positive 7 and negative 1. So I wanted to make sure you understand why you separate the equation into 2 equations. That distance, which is 4, could be to the left or to the right. And that's why you have to solve 2 equations. Now the 2 good examples in your book are, what did I say right here? Page 50, example 9. Oh, just one good example. Example 9 is an excellent example. Before you do that, break the absolute value into 2 equations, you have to get the absolute value by itself. That's important. You got to get the absolute value by itself. So the first thing you do to that equation is subtract 3 from both sides. The 9 minus 3 will give you 6 on the right-hand side.
How did you get that it equals 6?
By subtracting 3 from both sides, by going this.
So get rid of that 3.
Yep. Because my goal right now is just get the absolute value by itself. So I subtracted 3 from both sides and had this. And then I divided both sides by 2 and had this. The book just did the subtracting 3 and the dividing in one step. I did it in 2 steps. That doesn't matter. What matters is we both have absolute value of x minus 5 equals 3. Which one of those numbers is the distance, the 5 or the 3? When you say absolute value of x minus 5 is 3, you mean 3 is the distance from 5. So x minus 5 equals positive 3, or x minus 5 equals negative 3. Those are the 2 equations you solve. And you come up with x equals 8 and x equals 2. Those are the 2 numbers that are 3 units from 5 on a number line. So absolute value equations, get the absolute value by itself, and then break it into 2 equations. All right, one more example in the book, and then we'll do some equations that are different than what we might have done in college algebra. The other thing we did in college algebra was solve some radical equations. If you remember, solving is all about undoing what is done to the variable. If the variable has something added to it, then you unadd by doing what? Subtract. If the variable has something multiplied by it, then you unmultiply by doing what? Division. If something is square rooted, how do you unsquare root? Square. How do you uncube root? Cube. So a couple good examples on page 52. Just like absolute value, if you have an equation with a radical in it, you want to get that radical by itself before you square both sides or cube both sides or whatever it is that you're going to have to do. So example 12, before you square both sides, subtract 3 from both sides. And then when you square both sides, don't forget x minus 3 squared is going to have a middle term, x squared minus 6x plus 9. And then what kind of equation is that? Quadratic because of the x squared. Since it's quadratic, we have to get it set equal to 0 and factor. If we couldn't factor, we'd have to use the quadratic formula. But this one would factor and give us the 2 solutions, 1 and 8. I said solutions 1 and 8. I should have said possible solutions 1 and 8. Yes, ma'am.
Why when they moved the x squared did it not change to
Oh, I see what you're saying. From this line to this line, why didn't it become negative x squared? Because actually they moved everything to the right. They actually subtracted 3x, which gave me negative 9x, and they subtracted 1, which gave me 8, and then they picked the whole thing up and flipped it over. The only way they kept that x squared positive was moving everything to the right and then picking up the equation and flipping it over. Now, the 2 times so far that I've said, you think you have an answer, but make sure it works. One was when we cleared out fractions. We saw that we could get a possible solution that we actually couldn't use because it made the denominator 0. The other time we get possible solutions, and then it may turn out that one of them doesn't work, is when we raise both sides to an even power. And there's a good note, if you believe in writing in your books, there's a good note on page 51. Raising both sides of an equation to, actually that's not the note I thought. Raising both sides to an odd power can introduce imaginary solutions. Okay, that's not the note that I thought it was. When you square both sides, when you raise both sides to an even power, you always need to check your answers. We got 1 and 8 right here. If I put 1 back into this equation, I can check that in my head. 3 times 1 is 1. No, 3 times 1 is not 1. Let me try again. 3 times 1 is 3. 3 plus 1 is 4. Square root of 4 is 2. 3 plus 2 is not 1. That 1 didn't check because I did something wrong. What did I do wrong? Nothing. It doesn't check. Why am I getting that it doesn't check?
Because for some reason I have 5.
What the heck have they done? The left-hand side is 5, the right-hand side is 1. 5 doesn't equal 1, so 1 is not a solution. Okay, I was reading it wrong. They agree with me. 1 is not a solution because you have 5 on the left-hand side and 1 on the right-hand side. If we check, I was looking at that red check mark and I thought they were saying it does check. 1 doesn't check. 8 checks though, because if we put 1 on the left-hand side, we get 8. If we put 8 on the right-hand side, we get 8. The left-hand side and the right-hand side are the same thing, so that equation has one solution, it's 8. All right, enough saying this is what you already should know. Let's look at stuff that's a little bit different than what we might have done in college algebra. Number 30 is a 4th degree equation. Got any ideas? Anything you'd like to try? I think somebody's thinking, well, maybe we should try this. What sometimes works with quadratic equations? Factoring. Factoring sometimes works with quadratic equations. Sometimes factoring doesn't work, and then we usually have to end up using the quadratic formula. But sometimes factoring works. So number 30, maybe factoring will work on that, but even with a quadratic equation, what do we have to do before we attempt to factor? You need it in standard form first. So let's get number 30 in standard form, and then keep our fingers crossed and pray that it'll factor. Because if it doesn't, we might be up the creek without a paddle. What's the only way we know to even attempt to solve something that has 4 terms? Grouping. All right, so now we're praying that it'll factor by grouping. Tell me what mistake I'm making right here. What's wrong with that? Actually, that would work. That would work. I think this would work as well, except for I made a mistake in my grouping. What you said would absolutely work, but since I've written it in ink and I want to do it this way, watch out. Don't ever catch the negative outside the parentheses, or it's not equivalent to what was on the line above it. That would give me a positive 15x, and that's not what I had before the parentheses. So I need to catch the negative inside the parentheses and change that to plus outside the parentheses. I just barely had room to squeeze in a negative right there before that 6x squared. What can you factor out of the first group? A 2x cubed. If I factor out a 2x cubed, what's left inside that first parentheses? Right, 2x plus 5. What could I factor out of the second group so that I would also have a 2x plus 5 left in parentheses? And I have to factor out the negative if I want to be left with the same thing inside this second parentheses that I have inside the first parentheses.
Say negative 3x.
Negative 3x is the GCF of that second group. And if I factor out a negative 3x, that does leave me a 2x plus 5. Because the beautiful thing about factoring is it's checkable. Just distribute the 2x cubed, distribute the negative 3x, and see if it gives you what's on the line above it. And it does. So my GCF is 2x plus 5. My leftovers are 2x cubed minus 3x. And that made me realize something else. Did anybody else realize what I just realized? You can factor an x. This will factor further. You can still factor out an x, which caused me to realize that I could have factored an x in the beginning. I probably should have. Anytime I factor, I should ask myself, is there a GCF? And there was a GCF there that I wasn't even paying attention to. It would be a plain old x. If you don't take it out at the beginning, then you have to take it out at the end. So I'm going to factor an x out of that second group. And I'm just going to put it out front because that's where I like my monomial factors. So far, so good. Factored out of x, I just put it out front because that's where I like my monomials. And now that I have it factored, I can say if three things multiply together to give you 0, either the first one has to equal 0, or the second one has to equal 0, or the third one has to equal 0. And now I'm solving those three equations. 0 is one solution. It works. If I put 0 back into the place of all the x's in the original equation, I'm just going to end up with 0 equals 0. That's true. So 0 is one of the answers. What kind of equation is the second equation? Linear. So I just subtract 5 from both sides and divide by 2. Negative 5 halves is one of the answers. I don't want to have to check it right now, but I could if I had to. What kind of equation is that second equation?
Hold on, how did you get
Yes, sir.
the negative 5 over 2?
I had to subtract 5 from both sides and then divide by 2. What kind of equation is that second equation? It's quadratic. It won't factor, but I could use the square root method. I could get the x squared by itself. And then what? As soon as you said take the square root of both sides, what bells and whistles went off in my head? Don't forget both the positive and the negative square root. So x equals plus or minus square root of 3 halves. And I'm so proud of myself because that was so much work. From the very beginning of that problem to there was so much work, and I know I have, actually, how many answers do I have? Yes, because the plus or minus gives me 2 solutions, and then the -5 halves and the 0. So I'm so proud of myself. I flipped to the back of the book, and that is not the answer in the back of the book. It has the 0, it has the -5 halves, it doesn't have that guy. Why is that guy not going to be the answer in the back of the book?
Fraction in a radical.
No self-respecting math book writer is going to leave a fraction under a radical.
So you-
On the test, I would count that right. I am so proud of you that you got that far, I'd count that right. But because I want you to check your answers in the back of the book, it doesn't do you any good to do an hour's worth of work and not know if it's right or wrong. So in your homework, I do want you to rationalize the denominator just so that you can check your answer. You can break that square root of 3 halves into the square root of 3 over square root of 2, and then how do you rationalize it?
Square root.
Square root of 2 over square root of 2. So the answer in the back of the book is going to be square root of 6 over 2. That's the third and fourth solutions to that equation. Now, actually, in college algebra, we did a little bit of that. I remember solving fourth degree equations that would factor. And if it'll factor, then factor it. I know that in college algebra, I didn't solve anything that had a rational exponent. I didn't solve any equations with fractional exponents. But here's what I'm thinking. What's the first thing you do with quadratic equations? Get it in standard form. What's the first thing we did on number 30? Get it in standard form. Got any ideas about what we should do on number 32?
Add 4y to this.
Get it in standard form. That's what we always do. Get it in standard form, which is set equal to 0. And then pray that it'll factor. Because if it won't factor, it may be a pain. But if it'll factor, we can solve it. If you were going to attempt to factor that, what would you do first? Just like we did in last night's homework, actually not even as ugly as last night's homework, we can take out the lowest power of the y's. So we can factor out a y. We may have to squint hard to figure out what that leaves us inside parentheses, but we can definitely factor out a y, and that'll leave us y to the something. We'll have to figure out what the something is, plus 4. What exponent of y would add together to this 1 to give me 4/3? If God whispers the answer, write it down. That's always right. If God doesn't, then you're going to have to subtract 4/3 minus 1. 4/3 minus 3/3 is 1/3. Great thing about factoring is it's checkable. If you're not sure that the right answer is 1/3 or that right exponent is 1/3, go ahead and write it down in pencil and then just check it. 1 plus 1/3, sure enough, is 4/3. If it factors, I can say either the first factor has to equal 0 or the second factor has to equal 0. And that's the 2 equations I'm solving. One of the solutions is 0. How do I get the other solution? How do I solve y to the 1/3 plus 4 equals 0? Get the y by itself. Y to the 1/3 equals -4. And then what does something to the 1/3 mean? Cube root, 1/3 exponent means cube root. How do you uncube root something? Cube both sides. Y is -64. Two solutions, 0 and -64. So what we're learning is that factoring doesn't just work on quadratic equations, it'll work on other equations too. Let's get them in standard form and then see if they will factor. Number 40 is already in standard form, but I've never factored with something with negative exponents. I think I could figure it out. I know that whatever I put as the first term of my two binomials, I know that those two multiplied together have to give me x to the -2. What could I put here and here such that when I multiply them together, it give me x to the -2? Because when you multiply two expressions with the same base, what do you do with their exponents? You add them, and sure enough, -1 plus -1 gives me back that -2. So I'm factoring with negative exponents now, and it's okay. And then I want factors of 35 that have a difference of 2.
7 and 5.
That's 7 and 5. And in order for them to give me a -2, what would these signs have to be?
Opposite of each other.
And which one has to be negative? The bigger one, -7 plus 5.
Is it always the bigger one that will be
The bigger has to be the sign of the middle term. In this case, the middle term is negative. It's a -7 plus 5 that gives me a -2.
So it has to be the opposite of the middle term. The bigger number has to be the opposite of the middle term.
That sounds like hocus pocus and something that you're gonna memorize and then forget on the test. So don't memorize hocus pocus. Think what adds to give me -2. If I put the negative here and the positive here, I could have just checked it. -5 plus 7 wouldn't have given me -2. -7 plus 5 is what gives me -2. So, are you thinking what's next? Or do you have a question about that step? Okay. So based on what we've tried on the other problems, once we get it factored, the next step is set each factor equal to 0 and figure out what we can do after that. What do you think we could do to that first equation? All right, let's see if that'll work. Add 7 to both sides, we get x to the -1 equals 7. Second equation, subtract 5 from both sides, and we get x to the -1 equals 1/5. No, I'm sorry, I'm telling you the answer. I got ahead of myself. Subtract 5 from both sides, you get x to the -1 equals -5. What R word pops in your head when you see a negative exponent? Reciprocal. So when I see x to the -1 equals 7, I think, what this means, some number, if you flip it, you get 7. What number, if you flip it, do you get 7?
Flip when you're not flipping.
The reciprocal means flip it.
So it'd be 1 over.
1 over, you said 7, right? 1 over 7? I thought you said 6.
I was saying turn the x reciprocal.
You could write the x as, or x to the -1 as 1 over x, and then clear out fractions and then blah, blah, blah. Or you can just squint and say, the number that I flip and get 7 is 1/7. the number that I flip and get -5 is what?
1/5.
-1/5. All right. (44). X to the 3/5 equals -27. I could change that to radicals, but I hardly ever change rational exponents to radicals. They were invented because radicals are harder. So if solving equations is all about undoing, how can I undo raising something to the 3/5 power? What would un-3/5 it? If you think what power could I multiply times 3/5? That would just leave me x to the first. X to the first is what I want. And if I say, what can I multiply by 3/5? That would just give me 1. It's 5/3. To un-3/5 something, you 5/3 it. You'll never see that written in a math book because it's not said very well. But you get my drift there. Un-3/5 something, you would raise it to the 5/3 power. So that would give me x equals -27 to the 5/3. Now to simplify that, what does -27 to the 5/3 mean if you write it with a radical? Cube root of -27 and then raised to the 5th power. That's -3 raised to the 5th power. That's 3, 9, 27, 81, 243. -243. All right. I have 3 more minutes. I need to write a note down for you, and we're about to discover that note on the C and the E part. On the C part, how do you un-4/3 something? Yeah, raise it to the 3/4 power. So what's going to happen here? Raise it to the 3/4 power. How do I know that equation has no solution?
Because there's not a 4th root of 49.
There is a 4th root of 49. I'd have to find it on my calculator. But there's not a 4th root of -49. You can't take the 4th root or an even root of a negative number. So this has no solution.
Does that mean the next one? But the next one, no.
Hang on just a second. Even root of a negative.
Whenever you put no solution, do we need to write that explanation beside it? Why
No, I'm just writing that for your notes so that you know the E part may turn out not to have a solution either, but it's going to be for a different reason. So that one's no solution because you can't take the even root of a negative number. The E part, when I raise both sides to the 4/3 power, doesn't have the same problem because I can take an odd root of a negative number. That would give me x equals the cube root of -8 raised to the 4th power, and that's 16. So I'm thinking, yay, gonna end on one that has an answer. Why is that not the right answer? When you check it, 16 to the 3/4, 4 through 16 is 2, 2 cubed is 8. But what's on the left-hand side? What caused that not to work? I told you that the only 2 times that you get possible solutions that didn't work were when you cleared out fractions and when you did what to both sides. Here's your other note. That was the other time I said you make it an answer that doesn't work if you raise both sides to an even power. If you square both sides or raise both sides to a 4th power, which is what we did on that E part, we got an answer that didn't check. All right, there were a couple more examples that we didn't get to. Try the homework. Homework's on the back of the page. I even typed out the whole solution to a couple word problems because I knew we wouldn't have time to get to them. Try that homework, and if you need to ask me anything, I'll do some more examples tomorrow. Yes, sir.